Hello everyone, I am Shilpa Rudrawar and today I will discuss DSP Unit 4, that is Z transform. Hope you all have gone through the notes shared by me. So let's start. So Unit 4, that is Z transform. So what is basically Z transform is? Actually transform is a technique which is used for analysis of signals and system. So you have gone through or you may know the word that is Laplace transform and Z transform. So what is basic difference between Laplace transform and Z transform? That is Laplace transform is used for analysis of continuous time signals and system. So in unit 1 we have seen what is the continuous time system, what is the continuous time signal, and discrete time system and discrete time signal. So Laplace transform is basically used for analysis of continuous time system, where Z transform is used for analysis of discrete time signal and system, which is in frequency domain. As I have told earlier, what is the advantage of having frequency domain analysis is that if you want to separate out any unwanted signal such as noise, it is not possible in time domain. So you need to have conversion of that signal into frequency domain. So you will be getting different component of frequency, and whatever you don't want, you can filter it out. So that is the advantage. So in Z transform, you can plot pole and zero plot, which is used for finding the stability of the system. And in digital filter design, it plays a very important role. So what is Z transform? So Z transform of x of n. What is x of n? X of n is a discrete signal. Will convert time domain signal x of n into z domain, that is x of z, where x is capital and here x of n, x is small. Just keep that thing in mind. So whenever you are having x of n, the z transform of x of n will be denoted by capital X of z, and z is a complex variable. So complex variable means it is having value u plus jv, that is u is the real variable and this is a complex variable. It is denoted by r e raised to power j omega, where r defined the radius of the circle, which is represented over here. So this is the total z plane, and you are having real part and imaginary part. The value of real and imaginary part may vary from minus infinity to plus infinity. So this is the thing that you know. So what is this circle represent? The circle of radius r1 in z plane. This is the z plane where circle of radius r1 is there, which represents all the value of z1, all the value of z1 having same magnitude r1 with variable phase. That is omega is the phase which is varying from 0 to 2 pi. So r1 is the magnitude and phase is varying from 0 to 2 pi. So this circle is also called as a region of convergence, where value of x of z, that is x of z, z transform, you are getting that are finite value. And if the system's output is finite, then the system is stable. So definition of Z transform, actually formula of Z transform is x of n, that is small x of n, is a discrete time signal, and capital X of z is the Z transform of x of n. So how to denote? What is the formula for that? So Z transform of x of n is equal to capital X of z equal to summation x of z into z raised to power minus n, where n change from minus infinity to infinity. As I told you, value of this u and v change from minus infinity to infinity. So your input can change. That is x of n can change from minus infinity to infinity. That is, we have studied causal, anti-causal and non-causal signals. So non-causal is having values from minus infinity to infinity. So this is what is the Z transform. Now, this whatever equation we have seen, it is for both sided. That is the time index, that is n, which has both positive as well as negative value, and that may change from minus infinity to plus infinity. And that case, this is called as two-sided Z transform, because I am taking minus infinity to 0 as well as 0 to infinity values of n. If this limit change from 0 to infinity, that is the system is signal is causal signal, which change from 0 to infinity. So at that time, this is called a single-sided Z transform. Only difference between this particular equation and this equation is that the limits of n is changing from minus infinity to infinity over here, but here it's changing from 0 to infinity. Rest of the things are same. So competition of z, x of z involves how to find this x of n. This is find by placing particular value of z and summing that part by keeping a value of n from 0 to infinity or minus infinity to infinity. So important concept, that is the region of convergence, ROC, capital ROC. What is that ROC? The value of z. This is the value of z for which x of z is finite and lies within the region is called as region of convergence. So earlier I told you, here this is the for value of x z, x of z is having finite value is called region of convergence. That is, beyond this, if I am saying that this is the region of convergence, beyond this system is having some infinite value, so system is not stable. Only for the value of z which lies in between this region, your system is stable. So this is very important concept, that is the region of convergence. That is, for the value of z, whatever the x of z you are getting are the finite one. So this is the equation, summation, where n is changing from minus infinity to infinity, and whatever the z transform you are taking, if that is the less than infinity, the system is having stability. Then system is stable. So what is the importance of this z transform? This z transform becomes infinite at location of pole. The pole cannot lie in the region of convergence. That is, it gives the boundary for stability. If poles are lying on the boundary of ROC, means beyond that system become unstable. ROC decides whether the system or filter is stable or unstable. Also, ROC determines sequence type, whether it is causal, non-causal, finite, infinite. To see more related to ROC, we will go to the summary of ROC of discrete time signal. This actually explains what type of discrete signal you are giving, then what type of Z plane or ROC you will be getting. So this will get clear again more uh, in detail after we will take certain examples. So before that, we'll just go through these things. So what is this summary of ROC? There are total 6 type of sequence we have taken. That is, first is the finite right-sided causal signal. So finite right-sided causal signal means it is having some finite values and it is on the right hand of the or right side of the n. So value is changing from 0 to certain value, not infinity, but it is finite value. So at that time, whatever the ROC, that is entire z plane, this is entire z plane except z equal to 0. So at this point the system is unstable, but other than that the system will be having some finite value, that is x of z is having finite value. Same way, second is the finite left sided, that is anti-causal. So just opposite of this, you are having some finite values, but that lies on the left side of the plane or waveform. So that is called as the anti-causal. In this case, your Z plane or ROC lies all over the plane except at the infinity it gives the infinite value. So rest of the point, that is at 0 also or at some n point, xyz point, you will be getting finite values of x of z, that is a Z transform. Third is the finite, that is two-sided. Two-sided means addition of this and this. So but this is the finite value of sequences. So here it is called as a non-causal, where only at 2 points, that is z equal to 0 and z equal to infinity, you will be having infinite values, our system will not be stable. But for the rest of the cases other than z equal to 0 and z equal to infinity, the value of x of z are finite. So this is the ROC or Z plane. Fourth case is that same way we have seen that finite right side is that is causal signal sequence. Same way we are considering now infinite case. So in infinite right sided, that is causal signal, your value of x of n, that is sequences, will change from vary from 0 to infinity. So at that case, what will be the ROC? So here you are able to see the circle with radius r1. So region of convergence will be exterior to this radius, circle of radius r1. So if the value of z, if you are taking, that is having this value, so it is lying, x of z will lie interior of this circle, and that's why system will be not having stability, that you will be getting some infinite values of x of z. But if the value of z is such that it lies in the exterior of this circle r1, the system will be stable. Same case in infinite left-handed sidal signal, that is anti-causal. So here exactly opposite to this, that is ROC, region of convergence, where the value of x of z are finite, that will be in the interior of the circle of radius r1. Now, if you combine these two, that is infinite two-sided, that is non-causal signal. So this will lie, that is ROC will lie in between R1 and R2. So exterior of this and interior of this. So like that, it is in between. So ROC, where the system will be having, or x of z will be having, the finite values will lie in this region, which is